This video is brought to you by the Chariotone Horsebreaker Professional Overdrive. The Horsebreaker crams two of the most highly sought-after pedal circuits into one enclosure, offering the same uncompromising component and build quality seen in the Centura. Choose between buffered or true bypass switching, and swap the signal path order for maximum compatibility with your pedal board. Legendary guitar tones can be yours for less with the Chariotone Horsebreaker, available now at the link in the video description. Hey everyone, Ryan here at Plague Scythe Studios, and welcome to what I think is the newest benchmark for the nerdiest piece of content on this YouTube channel, and possibly in the entire sphere of guitar. And I've said that almost same sentence in the last video that pertained to power amplifiers, which is what we're talking about today. And that last shootout I did had some, shall we say, unintuitive results. It didn't really change the way that I approach power amps or what I use or what I recommend to people depending on their use case, and this video doesn't either, but I have a way better appreciation now for why that is and the certain factors that matter on their own in isolation and interaction between different specs that matter and some things that just don't and that you can't base a decision off of. And as usual, be uncovering more marketing bullshit that this industry loves so much. And we'll be going through all kinds of graphs and figures and stats and stuff like that. So if you're into that kind of nerdy crap, then this is for you. Grab some popcorn, your bagel bites, your Mountain Dew, Doritos, double XP for Modern Warfare, whatever you're doing, and sit back and hopefully enjoy the show. So today we're going to be talking about 4 different power amplifiers, which don't cover, by any means all of the power amp designs out there, but it gives a decent high level in terms of some of the more common ones out there, as well as a bit of overlap so we can have direct comparisons between same spec amps in certain aspects, while you'll be able to see which ones matter, which ones don't. We'll be talking about frequency response, even power usage. So I got a new power monitor toy that I'll be taking advantage of here, which will allow us to talk about efficiency, even get into some distortion, some power amp distortion, which I generally shy away from entirely. So first things first, I'm going to give a quick introduction to the power amplifiers that are featured in this video. We'll go through some of the high-level specs of each one of these and kind of what they're doing differently from one another on paper. Then we're going to listen to a comparative demo where I'll record the same pre-amplifier sound through each one through the same mic'd up cabinet at within a decibel or so of the same volume, and that way you'll be able to hear what these sound like when we're just kind of trying to reproduce a clean signal in a guitar application. So, in no particular order, start with the Mesa Boogie Mark IV. This will represent the 50-watt Class A 6L6 driven American power amp sound. Now this is actually an 85-watt amplifier, but there's a ton of different switches and knobs and pulleys and levers that you can activate on this thing to make it react very differently depending on what settings you're using. So with the Class A switch engaged and at full power, it has a output rating of 50 watts with a Class A design. Normally it runs in a simulclass mode, which uses Class A, B, and A at the same time. We'll get into those differences in a moment. But for now, know that this is a sort of big boy tube representation of kind of classic Class A designs that you might associate with amps like Vox, for instance. Representing the other side of typical designs from across the pond, we have the Chariotone Gargoyle, another 50-watt rated amp, except this is Class AB and uses EL34 power tubes. The other obvious difference, just from looking at it, is this has a single presence control for the power amp. So this isn't one of those weird like rectifier circuits that uses presence of the preamp. And this has presence and depth. Also of note, this has 2 separate master volumes. So if you're using the preamp, which we will be bypassing in these because, again, we're concerned about the power section, then you have a master for the preamp, then you have a master output level for the power amp. So we'll be using this to kind of tweak our tone or output level, depending on what we're going for. This, however, has a presence and depth circuit, but it has no volume. It's a unbuffered effects loop we're going through, so the overall output level of this amp is determined by how much level you feed it. and it doesn't take much to get really, really loud. Learn that the hard way. So another power amp in the Class AB category, but now representing the solid-state MOSFET side of things, we have the Matrix GT 1000 Effects. Those of you familiar with this amp probably know that this is intended for quite a different purpose than your run-of-the-mill tube power section in a amp head, but it's still interesting to compare for a few reasons. One of those is because this is rated at 1,000 watts when you bridge the stereo outputs, and on paper that sounds like completely overkill, but as you'll soon see, it's actually not as different as you might think just based on the number alone. And then finally, our second transistor bass power amp, we have the Mooer Baby Bomb coming in at 30 watts, and this is a Class D affair, which you can about guarantee anything that you see that's this small that can power a cabinet is going to be Class D, almost without exception. We'll go into why in a moment. One thing to note, this is tiny, but it's not really quite fair because the power brick is larger than the pedal itself, whereas all these other amps have, their power section built in. So gotta keep in mind, this is the grand size we're talking about. And unlike the Matrix, which does not have any additional tone controls, this does have a warm and bright switch, kind of acts as like a presence bump. And that is the selection of power amps we're looking at today. The one thing I do not have that I'd kind of like to in this lineup, but not terribly sad about, is a small tube driven amp. So something in like the 20 watt category that uses EL84s or 6v6s. Generally speaking, even in the lower wattage side of things, say 15 to 30 watts, I tend to prefer amplifiers that use the larger EL34, 606, KT88 tube types. My cleans, crunch, mid-gain, lead, especially rhythm tones, generally don't rely on the kind of harmonic distortion quality that you can get out of some of those power amps that use those aforementioned smaller tubes. Not to say they don't have their place. I just don't have one because they're not useful to me. And the once in a blue moon I want that, I've got a lot of capable amp modeling software and hardware to cover it. So that is one thing that you won't see in this video, but you'll still be able to make some pretty informed conclusions based on the slim lineup we have here, because this actually covers a lot of ground. So before we jump into demos, let's go through a brief technical explanation of the different classes. And this is one of those things that it's a marketing buzzword nowadays more than anything, I think, where some people have this pre-notion in their head that this class is always better than this, end of story. And that's simply not the case. There are things about each one that suck objectively, and there are some things about each one that I wish all of them, exhibited that trait, but it's a trade-off with each design, as is anything. So let's start with the classic Class A example. When I hear the phrase Class A, a few names come to mind. We got Vox, Victoria, Matchless over here in the States, and they're all based around kind of the most fundamental power amp designs there are. Class A, if you want to picture this, and I guess the easiest way, when you think about power amplifiers, you got an incoming sinusoidal wave of some kind, and you want to amplify it, you want to make it louder and bigger, so you want to turn it into something like that. Well, a Class A amp, unlike basically all other classes out there, actually amplifies the full sine wave. So we're talking 360 degrees, both the crest and the trough. And between that and some other fundamental differences that are unique to Class A amps, it has a cool effect that may or may not be warranted depending on the sound you're going for, the application, but it also has some drawbacks, as you might expect. So one aspect that will absolutely not translate in this video is the touch sensitivity of Class A amps. It's something that I definitely pick up on when playing through this amp in that configuration. The slightest amount of change to pick attack or volume level, it's just a fast reacting amp to those minor differences that you don't hear in other power amp designs. They have a smoother compression profile. They are quicker to distort, so they have less headroom. That could be a good thing or a bad thing, depending on what you're going after. If you're a modern high gain player and you get 99% of your distortion from a boost pedal and a high gain preamp, then that's not something you're probably going to want to dabble into. On the other hand, the disadvantages of a Class A amplifier are all but indisputable, starting with its relatively garbage tier efficiency compared to its counterparts. We're talking in the 25% range. Without context, that doesn't mean a whole lot. Some of these designs can reach 80 to 90% though. So we're talking about every watt that comes out as power, you've got another 3 or 4, probably more, that's just being wasted to heat. And it's even worse than that because the peak efficiency of 25, maybe 30%, is actually only on the higher end. So that's if you're full bore max volume. Most of the time on Class A and even Class AB amps, the efficiency is even lower if you're playing at bedroom to kind of middle of the road jamming volumes. That may not matter to a lot of people, but what it does do is shorten your tube life. You have to have a beefier power section, output transformer, and a similarly spec'd Class AB amp simply is going to be louder. So 30 watts here does not equal 30 watts there. We're going to see that trend continue. So if you're willing to make those sacrifices for tone, then be my guest, but those are some of the things you will run into with Class A amps. Later on, Class B designs were eventually introduced to solve some of the shortcomings of Class A amps, but you'll practically never see these in audio applications. In fact, I can't name a single one off the top of my head because of this phenomenon known as crossover distortion. Again, Class A amps, they amplify the full signal, but Class B has this push-pull configuration going on where one side amplifies this part, one side amplifies the bottom part, and then they get jammed back together. The problem is when you stitch them back together, it doesn't actually come out the same way that it came in, and that is crossover distortion. So around that 0 area, it may not be accurately reproduced, which is a big no bueno for audio applications. It may not matter in less sensitive subjects, but that's why you'll never see a Class B guitar power amp unless you have a very exotic example that I'm not aware of. But if you do, it probably doesn't sound as good as any of the designs we're talking about here. So a lot of people smarter than any of us in this video came up with the Class AB design, which kind of takes the best of both worlds. The main technical difference to take away from a Class AB amplifier is how much of the wavelength is amplified. So again, Class A does the full 360 degrees. Class B does 180 degrees, so one on top, one on the bottom. But Class AB actually does a little bit of both. So you're looking at up to 200 degrees roughly. So one will go a little bit under the 0 mark, one will go a little bit over. The overlap parts cancel out, and you get practically no crossover distortion, or none that is perceptible or even matters. So that is kind of the great compromise between those two designs. And the efficiency is comparatively pretty good. We're talking in the range of 50 to 70%, 75% or higher for some really specialized designs. Probably not going to be that high in your run-of-the-mill guitar amp. And because there's less heat loss, the tubes are sitting idle more of the time. You'll have longer power tube life. You can get by with a less beefy output transformer. And you'll even notice that a similarly spec'd Class AB amp will be a little bit louder than a Class A amp of the same power rating. And that's why basically any contemporary amp that isn't, specifically going after some of those Class A tones, it's probably Class AB in the tube head realm, ranging from, Fender Bassman ripoffs to the most innovative of high gain amps. Again, not 100% accurate in that statement, but it's a pretty good rule of thumb. As you might expect, you do lose some of those advantages of Class A amps that many enthusiasts go nuts over, like some of that natural compression and touch sensitivity and whatnot. These are not as responsive, but again, for most high gain players or someone that gets a lot of their boost or dirt from a pedal or a platform like that, this really isn't going to matter. The main thing about Class A and AB is the size compared to what's out there nowadays. In fact, if you cut this amp in half and kind of accounted for the asymmetrical layout of the power section, that's about as small as you can make a Class AB amp. In fact, Orange has the Pedal Baby, which is touted as basically being about as small as you can make a Class AB amp with today's technology. And it's portable, it's not big whatsoever, but compared to modern amplifiers that can hit similar power ratings, some of which can fit literally in your pocket or in the inside pocket, at least of guys wear. Can't speak for women's jeans or anything, but yeah, it's still kind of sizable. So that is one thing you'll want to consider is, do I want a Class AB power amp that takes up 1U or 2U of my rack unit, or something that I can literally throw in the smartphone zipper on my backpack? And that brings me to Class D amplification. And even considering the relatively recent history of the electric guitar, Class D amps are kind of a young technology. I mean, this is stuff that was really perfected in my lifetime, and I can't say that about a lot of things I use. But this stuff is, it powers the world now, basically, from your probably your car stereo to everything that we have in our pockets to all these smart home speaker stuff. It's probably Class D. The reason that is because you can make really, really small Class D amplifiers. They are super highly efficient. We're talking 90% range. And the cool thing about that is it's not just 90% at max volume, unlike a lot of these other tube technologies, and not even tube specific, but ones traditionally associated with that. You can hit in the range of 20 to 30% output volume, and you're already hitting close to max efficiency, which is crazy. This stuff is really the way of the future, and I look forward to how we can keep making it smaller. But that is exactly why we can make things that are this size and still reach a power rating that is, within 30% or so of something this big. Obviously, this entire thing isn't power amplifier, but the scale is still nuts when you look at it like that. Now, Class D amps work in a dramatically different way compared to your traditional amplifier designs. The major takeaway is that the signal gets manipulated, it gets compared to like a triangle generator, gets turned into like a square wave type thing, goes through some pulse width modulation or PWM, same thing that a lot of computer case fans run on to change their RPM, and then low pass filter, and it gets turned back into a sinusoidal wave again. A good design, it's going to sound identical, just louder, which is what you want for an amplifier, right? The only room for error is if that PWM process isn't optimal. You can actually make some of that high frequency content not be reproduced accurately. Anymore, that's not something you have to worry about a whole lot, I find, especially with the stuff we're going to talk about today for guitar power amps. It doesn't really matter anyway, because guitar speakers chop off about everything past 5,000 or 6,000 hertz. So that's really out of range for any margin of error. But, for hi-fi, home stereo stuff, watch out for it. But again, consumer Class D amps nowadays, just like, they're a dime a dozen. Everything's good. So with a high-level overview of all of the amp classes involved in today's video, you might be starting to formulate what you like or what amplifier you're looking to buy next. But before you click on that Amazon or Sweetwater or Guitar Center link, I would urge you to listen to these demos and stick around to the end, because those descriptions of efficiency and how a signal is amplified does not necessarily translate into audio quality or tone. And I would argue that if you're not worried about power usage or any of this kind of stuff, it's almost irrelevant, because it's going to come down to the circuit and the technology it's based off of, and not necessarily one being better than the other. It's just different. So let's have a listen to the same recorded preamp sound reamped through each one of these power amplifiers. We're going to be connected to a V30 loaded 4x12 speaker cabinet, mic'd up with an SM7B microphones. It's a pretty neutral dynamic mic kind of thing. And I'm going to be recording this at within a decibel or so of volume. I didn't change anything in the recording, so you'll be able to hear they're really close, within the region of sanity that I could do this on my own. I didn't want to record this so loud in order to avoid, one, power amp distortion. I'm not interested in that yet. Stick around till the end of the video. And two, I didn't want to make the speakers do any weird compression or drive thing, any distortion in that sense. So I want to hear the raw sound of the power amp, and we'll be able to do that even more so towards the later part of this video. So that is all to say, the only differences between these clips is the power amp. So keep that in mind as you listen and you start to piece together what's going on. For those of you wondering, I also recorded a clean and mid-gain kind of signal through this setup, but the differences were even less than you might have heard in this last demo, so it was kind of a colossal waste of time, so I decided to axe those. In favor of that, let's take a look at some numbers and figures to put some quantifiable measurements to what you might have heard there. We'll start with the Class AB MOSFET-driven Matrix GT1000 effects. So the frequency response is what we would call flat, plus or minus 1 decibel. And a lot of that is well within the margin of error of the way that I'm testing this, since it's very imperfect. It appears to have some little minor amount of high frequency roll off, which again, probably attributable to the test. And even if it's not, speaker cabs, doesn't really matter. It basically 100% faithfully reproduces whatever signal you're feeding it, which is what you want a flat, stereo power amp to do, in theory. We'll talk about why that may not be the case for you in a moment. Moving on to its Class D solid-state counterpart, the Moorer Baby Bomb. You'll notice there's 2 lines for this graph now, since there's 2 modes, both warm and bright. The bright switch simply adds kind of a presence bump after 2K in the 3 to 4 decibel region, so this is kind of bring out more reactivity in the speaker cabinet, which is a term we'll return to shortly. But otherwise, the warm mode is basically flat. Now, to our ears, it's going to sound quieter, because as you see, even at the same master volume output level, that bright switch actually adds signal. It's not like a tilt EQ or anything. So that you might have to adjust for that if you're switching between modes. But the more interesting thing is that when you compare the warm mode on the Baby Bomb to the flat settings on the Matrix, aka no controls, you actually get basically the same response. The more interesting takeaway here is that at these nominal output levels, these, kind of not ear-bleeding territory in a room this small, but you could keep up with a drummer and a bass guitarist if you're jamming, they sound basically the same. They're both flat at the warm setting, and there's no tone controls here, so just it's what it sounds like. Which I didn't expect. In listening to both of those takes back to back, I don't hear a difference whatsoever. Maybe there's some dynamic differences even at this level that simply aren't going to come through when you mic it up. But seriously, playing at these volume levels, I hear nothing. And I didn't expect that because there is so much talk around, well, the Matrix is a Class A/B thing, so it has more tube feel and dynamics and response, and that may be true at higher levels, but for the way that I think a lot of people are going to be using a product like this especially, you're not missing anything. It's all marketing mumbo jumbo yet again, so score 1 for that category. The story changes quite a bit when we switch to the tube amplifier modes though, so for a bit more direct comparison, let's stick with the Class A/B example, and this should show you that, yeah, that class thing doesn't really mean a whole lot in terms of raw frequency response, because this is determined by the tube power amp design. And this is a phenomenon that recent viewers of the channel will probably be sick of seeing. It's a common reoccurrence. We talked about it in the cab clone video and the speaker video. This is what happens when you plug a tube power amp into a speaker. It actually reacts, it resonates based on the impedance, which changes on a per frequency basis. That doesn't happen in traditional solid state amp designs. So you get a big bump to that 100 to 120 hertz region, which you see as I turn up depth, it changes. And then the higher frequencies also react, and as you might expect, the present circuit handles that. In this case, the circuits can change depending on the amplifier, but the depth and present circuits are entirely additive, so there's no cut going on. That means the green line marked presence and depth at 0 is kind of your baseline power amplifier sound. So if we cut those out completely, or with the potentiometer set at 0, that's how the power amp naturally reacts, which is not flat. An interesting thing to keep in mind, as this shapes kind of what we think of as an overall guitar amp tone. Then looking at the Class A example, you'll notice an overall similar phenomenon, except we have a different range going on. And this is due to the way that Mesa Boogie implemented the presence circuit. So it's kind of weird where presence at noon is neutral instead. Presence at 0 actually cuts high frequencies, and presence at 10 not only adds to that high frequency content, it makes the entire amp louder. I'm not sure if they're messing with negative feedback or exactly what's going on in the circuit, but this is all to say that a presence control isn't necessarily the same across different amplifiers, just the same way that a tone stack isn't the same. It drives me up the wall. Real quick rant, pet peeve moment, but when people say cut the mids, or I set my amp at 6 and 3 and 7 to sound like Metallica, that doesn't work for anyone else's amp. Unless they're using the exact same setup, same cab, same guitar, it don't work that way. It's not a universal thing. Same deal with presence and depth. End rant. So this may look, really different. You might initially look at this and go, oh, well, there's the difference. This is that glassy thing people are talking about with Class A amps. Not true. You see, when we set these amplifiers to their neutral positions, as in no presence or depth on the Gargoyle and presence at 5 on the Mesa Boogie, the frequency response is basically identical. I can hear a touch of that tighter bass response that people throw around with the Gargoyle file, but I wouldn't really call it significant, especially by the time you put it in a mix or if you're playing out loud. And this just reinforces that point I had with the previous shootout, that for high gain or even most contemporary examples where you're either going completely clean preamp or really high gain preamp that you don't want to dirty up the power section, it just doesn't matter. Class A, what tubes you're using, this kind of stuff gets so overblown for this particular use case here. The thing that really matters is the circuit, all these additions. Do we have this dedicated output level or not in this case? Do we have a presence and depth control, or is the presence implementation kind of batshit crazy on this one? Do you have a presence at all? These are the things you really need to worry about for a clean power amp sound. And in fact, when you turn these things to their max positions with presence and depth at 10 here, presence at 10 there, they still sound pretty similar to me. A little bit of difference, but for as different as these are, they're really not, are they? When you compensate for how you use them. So this is all kind of a big warning that, if you're looking for just something to make your signal louder, to make it cleaner, a lot of the stuff that people claim is important really is not. Here's the thing you got to worry about. Frequency response, do you want it to do this because you want to use, a traditional tube amplifier or tube preamp through a tube amplifier setup? Or do you want it to be completely flat because you have an amp modeler system or something like that you're already taking care of this kind of response curve? Because stuff like a Kemper, stuff like Fractal Audio products, Line 6 Helix, they're already doing this, and that's why these amps exist. What about those players I mentioned earlier, though, that like to achieve their tones with an overdriven power section? It's not that uncommon, it's just a different way of going about things. So we really need to look at these amps when they start to distort in the power section. It's a very different sound than preamp distortion, and it's where some of these differences, these marketing terms, can actually start to come to fruition. It's simply not going to be something that I think a lot of players nowadays are really going to experience. So in order to get the overdrive phenomenon, I'm going to reamp every one of these power amps with a completely clean signal, or as clean as I could possibly get it using outboard gear. I want to stack some different clean boosts together to achieve anywhere between 15 to 30 decibels of clean boost. I'll tell you why. It's variable in a moment. And I'm going to let you listen to the reference signal. So I'll pump all that big clean boost thing right back in to my workstation. You'll be able to hear what that sounds like without a power amp. Then you're going to hear it with the power amp. I'll be taking a line level tap off of it, which means we don't introduce any other variables like speakers, microphones, whatever. At the end of the day, once again, the only difference you're going to be hearing is the power amp. And any distortion you hear, besides a little bit of maybe crunch you'll hear in the reference file, entirely power section overdrive. Not something we cover a lot on here, and I think you'll see why in a moment. So have a listen to each one of these power amps when we hit it with a ridiculous amount of clean boost. Now things are starting to get quite a bit interesting, I would say, and this is where the differences between the power amps start to shine or get dull, depending on which way you're looking at it. Before we jump into my overall analysis of it, though, I want you to see the numbers for both the signal going in and going out, because this tells a lot of the story that the audio simply does not. These are different amps, so they're going to react in a different way. So I had to use a different amount of boost to get them to overdrive, or not, as it were, for one of them. And then because they have different power ratings between them, the output level actually changed quite significantly, even though I was able to get different, or at least a relatively similar amount of distortion with different inputs. So this is where stuff like, 50 watts versus 30 watts versus having a master volume control versus not. This is where you'll start to hear those differences. So even if you didn't care about any of that, here's the thing to keep in mind. The Mark IV and the Matrix I hit with 27 decibels of clean boost. That is the exact same reference file you're hearing for the no power amp example. So I was able to get the Mark IV quite crunchy with that. Interestingly enough, I also got the Matrix to have the exact same output level, at least peak, at negative 7.1 decibels when ran into a direct line level setup. That's counterintuitive because this is a 50 watt amp versus a 1000 watt amp, but as it were, we're not hitting the sweet spot to where we can get that louder. There's more headroom there, but at the levels I was hitting it at, it just came out to be that way. Now with the gargoyle, because I don't have like an effects return level, I had to hit it with another 4 decibels of boost to get it to break up in the same way and get a similar output level. But as you might have heard, the overall distortion profile is pretty similar between these two amps. I do start to hear some of those Class A versus AB differences, and honestly, it might be coming down to tubes at this point. The truth is, EL34s, 6L6s, AT88s, they don't sound nearly as different as people like to claim they do. It really comes more down to the overall power amp design, and it's when they start to break up where you hear these things. But I've seen so many people fail blind shootouts, myself included, when you change not only power amps, but especially just power tubes between different amplifiers. So I think the main takeaway here is that you're really going to have to listen on an amp by amp basis if you want power tube distortion. Which one is your favorite? It's likely not going to come down to the kind of tube used. Now, my favorite example here is the Moore, because I only hit it with 15 decibels of clean boost compared to the reference signal, and it got crunchy. Very, very crunchy. In fact, I was only about here on the master volume, so seemingly I could hit it with a less hot signal and would still have some more clean headroom. But at less than half the dB rating of the gargoyle, this thing was about full-blown square wave territory. But even more interestingly, the output was almost 9 decibels lower than everything else. So this is where that 30-watt headroom starts to come into play, where it can't take as loud of a signal coming in before it starts to distort, and it can't actually push out as loud of a signal compared to the other larger amp design. So there's your drawback for your pocket style Class D amp. Looking at the other power amp waveforms as well, compared to the almost nearly perfect square wave of the Moore Baby Bomb, you have kind of a band-passed square wave on the gargoyle and more of like a high-passed square wave distortion on the Mark IV, which is kind of opposite of how the preamps work, which is really interesting to me. They're still pretty comparable though. And again, overall, it's not something that I can definitively say, this is what Class A does, this is what Class AB does. It's just what the amps do. Again, the matrix looks basically identical to the reference signal with no appreciable distortion going on. So what I can say is this thing is a beast. And I'm that much more impressed with this amplifier after viewing this data. The last thing I analyze we'll be looking at is the power usage of each of these amplifiers. And just like the frequency response data, don't necessarily focus on the exact numbers here. There's probably a decent amount of variability with this cheap equipment I'm using. I don't know what the error rates are, so I don't have like error bars or anything. They don't disclose that besides plus or minus 0.1 that the display reads. But again, look at the overall scale. That's going to be fairly accurate, and all of these numbers are averages of average stuff, so it should be a good indicator, even if the precise numbers aren't something I would trust to the nearest ones place or something like that. But with that, let's take a look at our first graph here of steady state idle power usage. This is probably not an industry standard calculation by any means, but I'm defining this as all these amplifiers being ready to go. They're simply not taking any incoming signal. So they're not doing any work besides maybe producing a little bit of, white noise or something like that. But the on-off switches are set to on, the tubes are heated up, the solid state amps are just, sitting there ready to go. So they're not actually doing any work, and any of the power you see here is, for all intents and purposes, 100% waste because it's not making anything louder. So it's either going to heat or noise that we don't want. On the lowest end, we have the Moore on the neutral warm position sipping a cool 1.6 watts. That is pretty impressive. Not a lot of, electronic equipment that I could point to that I own that doesn't, sip 5 or 10 watts just sitting there doing nothing. Let's like the Nintendo Switch. That thing is insane. So good showing from there. This is something that, I even if you're power conscious, I really wouldn't worry about unplugging it if you're not using it, besides just, giving the components more life. The matrix is also not bad at a relatively low 30-ish watts, which compared to its output level is, again, pretty impressive. Not great, not bad, considering that it's also running, a couple small fans, active cooling solution, and look how much bigger it is. So, again, I would chalk that up as a relative victory if you just plan on gigging with this thing. Then we get to the tube amps. Oh boy. So what you'll notice is that we've jumped from, a few percentage of the output level of the solid state amps to well over double, or at least in that case, about 1.5 times the output level. I don't think this figure alone really conveys the insane impact that this actually has on the power amp design. So we're going to switch to an efficiency graph to really drive the point home. Because think about it, before we're doing anything, this stuff is already sucking up more power than you could ever potentially output through a speaker cabinet. Whereas this is, it's chilling at about 3% its capacity for output power. This is, a time and a half already in complete waste. So, if we were going to call the Mark IV our baseline for efficiency, which is not a good one, considering that we're already killing a few watts by switching it from 85 down to 50. We're looking at about a 73% increase for the Matrix and almost 99% for the Moore. And even the Gargoyle's doing better at about 29%. Again, this is handicapped given that simulclass Class A switch, but this just goes to show how much of a power hog tube amplifiers are before you even hit it with any power. We'll come back to that figure in a moment. The next thing I want you to see is the static power usage at a normalized output level. And again, this is probably not industry standard testing, but the way I'm defining this is we're going to hit this power amplifier with a known output level, and to keep things consistent, I went with pure pink noise, 100% full spectrum, 10 to like 30,000 hertz or something like that, beyond the audio spectrum. But that way we get a relatively consistent signal. It's not like being hit with a guitar DI, and we can see just how much of an increase, how much the amplifier is actually doing to, create that sound. So looking at the Moore, where it was only idling at 1.6 watts, we've seen an increase to 17.8. which means, another 16 watts or so are being dedicated to actually amplifying the signal. Pretty good efficiency there, We're at roughly half the capacity, a little over half of what this thing can even output to get to that normalized output level. So, yeah, I would call that a win. The Matrix doesn't see such a dramatic win, but we're still only using about 65 or so watts there to achieve that amplification. So, you do some backwards math and you're still right around that peak Class AB efficiency of, 75-ish%. Still pretty good considering that we're not even at 10% of the theoretical maximum output of this amp in terms of audio watts. So again, very impressive stuff. Then we get to the tube amps, and honestly, this is probably within margin of error. Just looking at it, we're talking an increase of a couple watts, not even a watt for the Gargoyle, which means it just doesn't even care if it's amplifying or not. It's sucking up so much power just to sit there, which is why these things actually make really good space heaters, as it turns out. Not so great in the summertime, but in the wintertime, you got one of these in a desktop full tower like I have, you don't have to turn on the heat for quite a few months out of the year. It's crazy. I knew this stuff intuitively. Obviously, tracking guitars or doing a demo, yeah, this stuff gets warm in here. But seeing it in this format is really eye-opening for me. And again, I'm the one that's doing these tests, so I'm sure it's going to be really surprising for some people. I wanted to convey this gargantuan gap in power usage in hopefully a more obvious way, as well as fact check some of these efficiency numbers I was quoting earlier. So I came up with this first 40 dB of efficiency. I'm sure this is not industry standard and probably extremely flawed. But nonetheless, I think the scale still shows a very important trend. So what I did was measure the noise floor of these amplifiers and the power usage at no amplification. So we're looking at idle versus static usage. Then I amplified a signal 40 decibels, through the various controls, again, pink noise, and then measured the power usage there and compared the two. And indeed, what I found was the Class D Moore Baby Bomb is roughly 91% efficient for the first 40 decibels. That's nuts. That is super impressive that only 9% of the energy going into a device like that is wasted. What other thing can you name that is that power efficient? Very, very cool. The matrix ain't bad. We're looking at right around the theoretical limits of most Class AB amplifiers at 70%. And I'm sure we could get that a little higher at louder settings. So very, very nice with that as well. The tube heads are garbage. We're looking at a 2% efficiency increase, which means it just doesn't care. Maybe we'll see better results as we crank these things wide open, but at non-ear bleeding levels, they just don't care if they're amplifying or not. They're going to be spitting out heat left and right. So unless you're someone that counts every little kilowatt hour on your power bill, or you're maxing out like a 15 amp circuit at home or something, this isn't stuff that I would necessarily worry about all the time, but it can add up. And at the very least, this should show the differences between, a solid state Class D thing at the high end and a more traditional Class A or Class AB tube design on the low end, and how even, two Class AB amps aren't necessarily comparable because they are based on different technology. So with all of this information in mind, hopefully this was of academic interest at the very least. But the major takeaway for me is that these things are epic for amp modelers, because their lack of really any frequency response manipulation is exactly what you want when you have a line level thing that already does what an amplifier head does. Something like an Axe Effects already plots that frequency response curve in its amp block. So you don't want two tube heads cascading together in that way. So with that in mind, you really shouldn't be using pedals like these with, say, a rack tube preamp. Don't put a tri-axis through this thing. It needs some power tube coloration. But if you have a wet, dry, wet signal, or you have, a pedal rig that does model a tube head, then this is a perfect candidate for it. And honestly, the way this thing breaks up, and with this bright switch, you can kind of fake a little bit of tube tone out of this. It's not perfect, but I wouldn't really mind just playing one of those more micro preamp pedals through this without any tube power amp simulation. Wouldn't be the worst thing in the world. But these amp heads, their power amps are built for their preamps. They're matched really well. And if you want to put another preamp sound to the effects return that work, I wouldn't double stack them, obviously, but that's really the major things you're hearing. Everything else is going to come down to an amp by amp basis and the way that you want to use it. So recommendations: Class A is cool for certain things. Class AB is what most high gain tube heads are nowadays, so just don't worry about it would be really my recommendation there. If you're using amp modelers, these are great. If you're not in need of 1000 watts of power, most Class D things are going to suit you just perfectly. And this has been a real eye-opener for me, because I always held this in like higher regards than the Baby Bomb, but honestly, I'm super impressed with this thing even more than I was when I first reviewed it a couple years ago. Yeah, that pretty much does it. Damn, this video took a long time to make and film. So if you do like it, please let me know. Comments below, any other questions or content suggestions. I will take them. Pretty booked for the next couple months though, so might be pushed to the back burner. Thank you so much for watching. We'll see you next time. Bye.